Welcome back to another video on the Maths channel. It's your teacher Mr. Lim here, and in this video we're going to be looking at HSC questions with reference to angles of elevation and depression. Before we begin, let's go through some key information. So the angle of elevation is actually equal to the angle of depression, because alternate angles are equal on parallel lines. So here we've got the angle of elevation, here we've got the angle of depression, and they are equal. So if a question tells you that the angle of elevation is 30 degrees, the angle of depression is also 30 degrees. If a question tells us that the angle of depression is 67 degrees, then the angle of elevation is 67 degrees. Okay, they are equal because alternate angles are equal on parallel lines. Alright, now that we've got that out of the way, let's have a look at some HSC questions. This one is question 3 from the 2006 paper. The angle of depression of the base of the tree from the top of the building is 65 degrees. So let's put that in first. We know that it says the angle of depression, which is depressed because it's not part of the triangle. So it's quite sad. Here's my 65 degrees, and therefore the angle of elevation is also 65 degrees. The height of the building is 30 meters. How far away is the base of the tree from the building? Correct in one decimal place. So we know this is 30. We want to know how far this is. So I'm just going to use trig. I'm going to label the sides in reference to this angle here. So 30 is opposite, x is adjacent, so I'm using tan. So remember SOHCAHTOA, the only ones with opposite and adjacent O and A is t, which is tan. So we got tan of the angle is equal to opposite over adjacent. Whenever x is in the denominator, we can swap them. So I'm going to swap these two together. We get 30 over tan 65, and we can put that in our calculator. $13.99. So the answer is B. Right. This next question is question 4 from the 2011 paper. The angle of depression from a kookaburra's feet to a worm on the ground is 40 degrees. The worm is 15 meters from a point on the ground directly below the kookaburra's feet. How high above the ground are the kookaburra's feet? Correct to the nearest meter. So we want to work out what this is. I'll just call it h for the height. The angle of depression is 40 degrees, therefore the angle of elevation is 40 degrees. And now I can start labeling my sides in reference to this angle down here. Height is opposite, 15 is adjacent. Again, I'm going to be using tan. So the tangent of the angle is equal to opposite over adjacent. Here we've got the pronumeral or the unknown in the numerator. In the denominator we've got an actual number, so I'm just going to move that actual number to the front. So h is equal to 15 tan 40, and we can put that in our calculator to get 12.59. To the nearest meter, that's 13 meters, so the answer is C. Right, this next question is from the 2015 paper. It's question 9. From the top of a cliff 67 meters above sea level, the angle of depression of a buoy is 42 degrees. So depression 42, but we also know elevation is 42. How far is the buoy from the base of the cliff, call that x, to the nearest meter? Opposite adjacent. Remember, we're doing it in reference to this angle here, inside the triangle. Again, we're going to be using tan. Tan of 42 is equal to opposite over adjacent. I'm going to swap these two. X is equal to 67 over tan 42. Which is 74.4. To the nearest meter, that's 74 meters, so the answer is B. Alright, question 12. Of the 2019 paper, an owl is 7 meters above ground level in a tree. Let's draw that out, because we don't have a diagram. So we know it's 7 meters above ground level. The owl sees a mouse on the ground at an angle of depression of 32 degrees. So here's my owl, here's my mouse, and the angle of depression, which is outside the triangle, is 32 degrees. Okay, the most common mistake that students make is when they see the angle of depression, they think it's this part of the triangle. Okay, but it's not part of the triangle, that's why it's depressed. Okay, so depression is out here, which is equal to the angle of elevation 32 down there. How far must the owl fly in a straight line to catch the mouse, assuming the mouse does not move? So we want to work out what this is. Okay, fly in a straight line to the mouse. Now that I've done that, let's label this triangle with reference to this angle of 32 degrees down here. 7 is opposite. X is the hypotenuse, so we're going to be using sine. Sine of the angle is equal to opposite over hypotenuse. Swap them, we get X is equal to 7 over sine 32. Which is 13.21. So, looks like the answer is D. Alright, question 20 of the 2008 paper. A point P lies between a tree, 2 meters high, and a tower, 8 meters high. P is 3 meters away from the base of the tree. From P, the angles of elevation to the top of the tree and to the top of the tower are equal. So whatever this is, if this is 40 degrees, then this one is also 40 degrees. What is the distance x from P to the top of the tower? Okay, so in order for us to do this, we actually need to work out how big this angle is. So I'm going to be using this triangle here to work out what this angle is. And because we know that these two angles are the same, I can just use that here. Alright, so I'm going to call that theta, because that's the angle I want to work out. This is opposite, this is adjacent, so I'm going to be using tan. So the tangent of the angle is equal to opposite over adjacent. So theta is equal to the inverse or the arctan of 2/3. Whenever we want to work out an angle, we need to press shift. So shift tan of 2/3 is equal to 33.69 degrees. Therefore, this here has to be 33.69 degrees as well. Alright. Now let's look at this big triangle here and work out the value of x. Let's label the sides. Opposite of that angle is 8 and the x is the hypotenuse. So we're going to be using sine here. Sine of the angle is equal to opposite over hypotenuse. I'm going to swap these two. We get 8 over sine of 33.69. So we've got 8 over sine of that answer from before, which is 14.42. meters. So the answer is D. Alright, let's have a look at question 23 of the 2009 paper. This is part A, part 1. The point A is 25 meters from the base of a building. The angle of elevation from A to the top of the building is 38 degrees. Show that the height of the building is approximately 19.5 meters. So this is the height that we need to prove that it's 19.5. So that's opposite the 38 degrees. This is adjacent to the 38 degrees. So we're going to be using tan. So part A, part 1, tan of 38 is equal to opposite over adjacent. So the height is 25 tan 38, which is 19.53 meters, which is approximately equal to the 19.5 meters as required. So whenever a question asks you to show that, it means show all your working, and once you've gotten the answer, just write as required in your final line of working. Alright, what about part 2? Part 2 says, what is the angle of depression from the top of the building to the car? So it wants us to work out what this is equal to, but we know whatever that is, it's the same as the angle of elevation. So all we need to do is work out the angle of elevation. We've already shown that this is 19.5. So I'm going to label this as opposite to that angle. And this one here is adjacent. So again, I'm still going to be using tan. So tan of the angle is equal to opposite over adjacent. So theta is equal to the inverse, or the arctan of 19.5 over 62. Which is 17.46. Now this one says correct to the nearest degree, so I'm just going to say 17 degrees. And I'm just going to write a concluding statement because it says angle of depression. Therefore, angle of depression is 17 degrees. Alrighty. This is the last one for today. Question 24 of the 2010 paper. Part D. The base of a lighthouse, D, is at the top of a cliff 168 meters above sea level. The angle of depression from D to a boat at C is 28 degrees. The boat heads towards the base of cliff A and stops at B. The distance AB is 126 meters. Alright. Part 1. What is the angle of depression from D to B? So it's asking us to work out what is this equal to? I'm going to call that theta. Now, because angle of depression is equal to the angle of elevation, so maybe I'll just draw that in. That means that this bit here is also theta. Okay, so if we work that out, technically we've worked out the angle of depression. Don't know why this is 3 marks, but let's have a look. So according to this here, 168 is opposite that angle and 126 is adjacent. So we're going to be using tan. So the tangent of the angle is equal to opposite over adjacent. So the angle is equal to the inverse tan of 168 over 126. which is 53.13 degrees. And the question says to the nearest minute, so I'm just going to press my degrees, minutes, seconds button here. 53 degrees and 8 minutes. Okay, this is 48 seconds. Because there are 60 seconds in a minute, if this is over 30, over halfway, then we need to round the minutes up. It is, that's why I've rounded up to 8 minutes. So therefore, angle of depression from D to B is 53 degrees and 8 minutes. Alright, what about part 2? How far did the boat travel from C to B? Correct to the nearest meter. So how far is this? I might call this X. Actually, I might scrap that. Okay. So what I would probably do is I would probably work out how long this entire side is. In order for me to do that, I'm going to have a look and see what this angle is. Well, we know that that angle has to be 90 degrees minus the 28. And 90 minus 28 is 62. So this is 62 degrees right here. The side that I've highlighted AC in green, that's AC, and we've also, that's opposite to the 62, and we've got the 168 here, which is adjacent to the 162. So O and A, I'm going to be using tan. Tan of the angle is equal to the opposite, which is AC, over adjacent, 168. So AC is therefore equal to 168 tan of 62. Which is 315.96 meters. So that's AC. But we need to work out what BC is. Therefore, BC is just AC minus AB. Right, the whole length minus this small little bit. That will give us BC. So that's 315.96 minus the 126, which is 189.96. Then the question says correct to the nearest meter. So I'm just going to round that to 190 meters. Alright, so that's it. Those were a few of the questions that I could find from actual HSC papers with particular focus on angles of elevation and depression. I hope you found this video helpful. If you did, please give it a like and a subscribe. Otherwise, I will see you in the next video. Have a great day. See you.